Hello, good day viewers. In our previous lesson, we have learned that a complex number can be transformed into an exponential form as z equal to re to the I theta. So in this tutorial, we are going to transform some complex numbers from rectangular form to exponential form. And we have only 4 problems. You can see them right here. So let's start with the first one. All right, here is the first one, z equal to 1 plus root 3i. And the exponential form, remember, is equal to r e to the I theta. So we only need to find two things, the r and the angle, right? The radius, which is the modulus. So let's start with the modulus. R, remember, is equal to the square root of what? The real part squared plus the imaginary part also squared. 1 squared is 1, root 3 squared is 3, 1 plus 3 is 4, square root of 4 is 2, and therefore r is equal to 2. So what about the angle? If you observe, this is in the first quadrant, so we don't have problem with that. Therefore, theta is equal to tan inverse of imaginary part divided by real part, root 3 divided by 1. Root 3 divided by 1 is root 3, and tan inverse of root 3 is 60 degrees or pi divided by 3. Let us use radian. Therefore, theta is equal to pi divided by 3. So what happened? We have our theta and we have our radius. So what is the exponential form of this complex number? It will be equal to r, which is 2, e to the I theta, and our theta is now pi divided by 3. And hence, we have just transformed this complex number into its exponential form. Let's take the other one. All right, here is the second one. Z is only equal to I, so the real part is missing. So if you should construct this, you know it is going to lie on y-axis here, right? Therefore, the angle subtended is what? 90 degrees or pi divided by 2. And what about the radius? You know the coefficient of I is just 1, so the distance here is 1 because r is the distance. So r is equal to 1, and our theta is equal to 90 degrees or pi divided by 2. And so we can transform this complex number into z equal to r, which is 1, we don't have to write it, e to the I, theta is what? Pi divided by 2. And from this, you'll be able to transform it back into this. It's all the same. So now let us take problem number 3. All right, here is problem number 3. You can see z equal to negative 2 plus 2i. I think this is in the second quadrant, which is less than 180. So if we should take reference from the first quadrant, we are going to subtract whatever we obtain from 180 degrees. So let's start by finding the radius. R equal to the square root of negative 2 squared plus 2 squared. Negative 2 squared is 4 and 2 squared is 4. 4 plus 4 is 8. And square root of 8 is what? 2 root 2. Therefore, r is equal to 2 root 2. And what about the angle? Remember, this is in the second quadrant, which is less than 180. Therefore, whatever we obtain, we have to take it away from pi, which is 180. Then tan inverse of what? 2 divided by 2. We are taking everything positive because in the first quadrant, everything is positive. 2 divided by 2 is 1. Tan inverse of 1 is pi divided by 4. So our angle is now equal to pi minus pi divided by 4, which is equal to 3 pi divided by 4. So our angle is what? 3 pi divided by 4. We have gotten our radius already. So now let us substitute. Our z will be equal to r, which is 2 root 2, e to the I theta, and theta is 3 pi divided by 4. And now let us take the last one. The last one, we are given only z equal to negative 1. If you have the graph of this, you know negative 1 is in the second quadrant, this leg down here. The distance is negative 1, and therefore the absolute value of negative 1 is 1, which implies that what? r is equal to 1, and the angle from the standard position down to this terminal point is pi, or 180 degrees. Therefore, the exponential form of this complex number will be r, which is 1, we don't have to write it, e to the I theta, and theta is what? Pi. As simple as this. So in our next class, we are going to see how we can transform the exponential form back to the rectangular form. Thank you for watching. Do share to your learning colleagues, and don't forget to subscribe to my YouTube channel for more exciting videos. Bye bye.